Hi everyone! Today we will be learning NumPy, a package widely used in the data science community, which lets us work efficiently with arrays and matrices in Python. First, let's import NumPy as np. This lets us use the shortcut np to refer to NumPy. Now let's make our first array. We can start by creating a list and converting it to an array. So here's our first NumPy array. We can do it more succinctly by passing the list directly. Now let's make multi-dimensional arrays by passing in a list of lists. We passed in two lists with 3 elements each, and we get a 2x3 array. We can check the dimensions by using the shape attribute. For the aRange function, we pass in a start, a stop, and a step size, and it returns evenly spaced values within a given interval. So suppose we wanted to convert this array of numbers to a 3x5 array. We can use reshape to do that. The linspace function is similar to aRange, except we tell it how many numbers we want returned, and it will split up the interval accordingly. We can use resize to change the dimensions in place. NumPy also has several built-in functions and shortcuts for creating arrays. Ones returns an array of ones. Zeros, an array of zeros. I returns an array with ones on the diagonal and zeros everywhere else. And diag constructs a diagonal array. To create an array with repeated values, we can pass in a repeated list, or we can use NumPy's repeat function. Notice the difference between the two outputs. We can also combine arrays to create new ones. Let's create a 2x3 array of ones and stack it vertically with itself multiplied by 2. And here's the same thing, but stacking horizontally. Now let's look into some of the operations you can do with NumPy arrays. Performing element-wise addition, subtraction, multiplication, and division is straightforward, as is raising all the numbers of an array to a power. For those familiar with linear algebra, the dot product can be done using the dot function. Let's create a new array using a previous array y and its squared values. The shape of this array is 2x3. We can also take the transpose of an array using the t method, which swaps the rows and columns. The shape of the transposed array is 3x2. Using dtype, we can see what type of data the array has, and with asType, cast an array to a different type. NumPy also has many useful math functions that we can use. Let's look at a few commonly used ones. Here's our new array A. And we can look at the sum of the values in the array, the maximum and minimum, or the mean and standard deviation. To find the index of a maximum or minimum value, we can use argmax and argmin. Next, let's learn about indexing and slicing. Let's create an array with the squares of 0 through 12. We can use bracket notation to get the value at a particular index, and the colon notation to get a range. The notation is start, end, and step size. Specifying the starting or ending index is not necessary, and we can also use negatives to count back from the end of the array. For our first example, let's take a look at the range starting from index 1 and stopping before index 5. Next, let's get a slice of the last 4 elements of the array. And here, we're starting 5th from the end to the beginning of the array and counting backwards by 2. Let's see how this extends to a 2-dimensional array. First, let's make a 2-dimensional array 0 to 35. We can get a specific value by using the comma notation. Here's the value at the second row and second column. Now, let's use colon notation to get a slice of the third row and columns 3 to 6. We can also do something like get the first 2 rows and all of the columns except the last. This is how we would select every second element from the last row. We can also use the bracket operator to do conditional indexing and assignment. For example, this will return an array that is the elements of our original array that are greater than 30. And this assignment will take those elements within our original array and assign them to a new value. Here, we're capping the maximum value of the elements in our array to 30. Next, let's look at copying data in NumPy. First, let's create a new array R2, which is a slice of the array R. Now, let's set all the elements of this array to 0. When we look at the original array R, we can see that the slice in R has also been changed. So this is something to keep in mind and be careful about when working with NumPy arrays. If we wish to create a copy of the R array that will not change the original array, we can use rcopy. We can see that if we change the values of all the elements in rcopy to 10, the original array R remains unchanged. Lastly, let's learn how to iterate over arrays. First, let's create a 4 by 3 array of random numbers from 0 through 9. We can iterate by row by typing for row in test, for example. We can iterate by row index by using the length function on test, which returns the number of rows. We can combine these two ways of iterating by using enumerate, which gives us the row and the index of the row. Let's make a new array, test2. If we wish to iterate through both arrays, we can use zip. NumPy has a lot to offer, so be sure to look at the documentation to find out about more great features. Thanks for joining me. Hope to see you next time.